Good people, we are back. In our last tutorial, we did division and modulo, and I hope everything is clear. Everything was clear. In case there are questions, you can leave them in the comment section. Now let's proceed to our today's lesson. Today we're going to learn about we're going to proceed from where we left. We're going to cover module basics, maybe some math modules, random numbers, and so forth. Okay, so to start us off, I should say the Python code we've been running initially. We've been running them on scripts. So basically, we write our code in a script, then we execute the script. Now, I'd like us to get started on modules. What are modules? There should be a folder on its own. No? Yeah. So we do modules. We can do in Python, a module is maybe a description of a module. A module is a file containing Python code that can be used by other module or scripts. Oh, that's clear. A module is a file containing Python code by modules scripts. So a module is a file containing Python scripts that can be used, Python code that can be used by other module or script. How do you use a module in another file or another script? To use a module, we use the keyword import. Basically we use the import statement to make the module available for use in the other module. In the other module we want to use it in. So we use the statement. It's a statement, not a keyword. We use a statement import. So it's available. Once you have imported the module, any object divided in any objects available in that module can be accessed using the dot notation. How that's clear? Once imported, the objects or any objects available in the module can be accessed by using the dot notation. We'll do examples to see how that gets to work or that gets to life. But basically, this is what we should know about modules. We import a module, then any object available in that module can be accessed using the dot notation. I will see it in a little bit. For example, I'll write two modules here, then we'll see how we import it and how we use it. So I'll have two Python scripts. The first one I'll call it names.py. Here I'll have first is equals to Larry. First is equals to Mary. Now here's our first file. Now we want to print the names, but we want to print in another file. So I'll call this names print. So what do? First we're going to import, as we just said in our characteristics here of a module, that to use a module we use the statement import. Here is how we just do. We're going to import names, right? So when you say import names, we're importing this file. Now let's try and print hi Larry and hi Larry and hi Mary from our names file. Let's do a print. We're going to say hi. Let's do yes. Now we're going to use, where do we see the dot notation coming in? Now in our print statement, in our next print statement, we're going to say print names dot first. What does that mean? This means okay, let me finish writing and then I can explain. Okay, this means that in our file, in our script, in line 4, we're going to print names, which is the name of the script, and then inside the names we pick the first. Now I guess you can now guess how to print how we're going to print the second statement. So we're going to copy this, going to paste, but then we're not going to repeat the first, but we're going to print the last. So we're going to print the first, then the second in just in the same line. Let's see how that goes. So we're going to go to modules, then we print say Python names print. Let me see. I'm sorry. Sorry for that. I did not run the script. I did not complete. I should have completed the script. Yeah, I had not completed here. It wasn't complete. That's why we had an error. Now, when you run the script, this is the script you're running. You're going to see hi. Then we have Larry, Mary. I'm going to give us as okay. That's the output we're having from the script. We've imported the names from the names file. We've imported the names from the names file, as we stated here. We have used the import names. Once we import, we've been able to access the first name and the last name. And as we said here, we're going to use the dot notation, whereby it's basically the dot names dot, the same way the way we said names dot first and names dot last. So had we had other variable names and you want to access them, we could be able to access them through. We could be able to access them using the dot notation as well. So basically, a script is a file containing Python code that can be passed to the interpreter. A module is a file containing Python code that can be imported by a script module to interactive interpreter. I hope that's clear between our script, a module. For us to execute the contents of a file containing Python code and make available the element from that file, use the import keyword. Import statement, not keyword. For the dot notation, basically we're trying to reference an object, the imported file, the imported module. I hope that's clear. Now let's talk something about importing modules and executing scripts. Once a module is imported, basically this is a take through how the importing modules and how to execute scripts in Python works. Basically an introduction or an explanation of what exactly happens when you run the script, right? So when a module is imported, what happens? You've imported a module, right? All the code in the module is immediately executed. I hope that's clear. And we've seen in our example as shown as I showed in a minute ago. Python programs often use built-in special name __ name _ to determine the file was executed as a script by the programmer or imported by another module. Okay, there is in Python there's a built-in special name which Python used to determine whether the file was executed as a script by the programmer or imported by another module. If the value of the name of the string is main, then the script was executed by. What I'm trying to say is, how does a Python script know whether the module was imported or it was run as a script? So Python has a built-in special name, this one, special name, which determines if the file was executed as a script by the programmer or imported by another module. I hope that's clear how Python uses basically that expression. Python has a name which is just to know whether this is a script or it's an imported module. Okay, we can proceed to. Okay, I can give an example of where the name keyword is used to check if the file is being executed by the programmer or it's imported by a module, right? I'll show that in our coming examples. For now, let's I hope the introduction to modules is clear, and we've seen how to import modules and how to go about it. So we can now talk about math module. So in our previous programs we've done about simple mathematics calculations, expressions, and the numeric types. Despite that, Python has a standard math module. So despite us having the simple addition, division, subtraction, multiplication, and parentheses and the like on the modulo, Python has a standard math module that supports advanced math operations. So Python has advanced math module that has basically Python has advanced math module that is used to do advanced calculations advanced math module are used to calculate advanced math operations that handles Python has a math module that handles advanced math operations. A module, okay, I have explained this previously, that a module in Python is co-located in another file. Programmer imports the module for use in their own file. I hope that's clear. Basically, I can do an example to show example of I can do math.py. So basically, we've said Python has a math module, so we're going to import the math module. Now we imported the math module. We have a number of let's we're using this as an example, a variable number which is equal to 49. We want to do a square root, right? Let's do a square root. Since let's do that is equals to, let me do a number which you can literally, let's do 9, because 9 squared is 81, so it will be easy for us to calculate that. How do we do that? We do math dot square root. I hope it's clear how we're able to. So we've imported math module. Then we say math using the dot notation here. Then you're doing a square root, which is now in the module, square root of what we have. So square root of our number, right? So we print. We print num square root, basically the square root of the number. Then we run the file as Python. Okay, math has not to do square root. Let me see what math module square root. I have picked. I have used a wrong. Let me see. I have picked a wrong way of doing a square root in. This should work though. Why isn't it working? Let me see. Okay. When we print our code here, when we run our file here, the reason why. Okay, let's see the error. Let's just try and. Oh, no. Okay, let's see. Let me rename this to. Okay. Let's just I can call it example 1. Okay, I don't know if that was the error, but let's try and run. Okay. Square root of 9 is 3. I noted it one as I was squaring it initially, but square root of 9 is 3. Okay. Now, I came to my conclusion that you can't give a name to your script to a module name, because we're importing from a module called math. So basically, there's in the module there's a file called math.py. So you can't repeat the same. That's why we were having an error here. But once we changed that, we were able to find a solution, which our square root is square root of 9 is 3. Square root of okay, we can do any square root we want to. Now you can do a square root of what which brings our answer to 9. I hope that's clear. We've seen how we can use a math module. So this square root here, this one, it's a function, right? So in our math file, in our math module, since we're importing math module, we have a function called a square root. So now we're being introduced to a new word called functions. So the square root in our file is a function. So if you ask yourself what's a function, so a function is a list of statements that can be executed and be executed simply function is a list of statements that can be executed by referring to the function name. How that's clear? We'll cover about functions as we go along. So that's okay. We have shifted from math module. Within a math module, we saw a function called square root, which takes in parameter number. And now we've moved to dealing with functions. So functions are a list of statements that can be executed by simply referring to the function's name. Hope that's clear. Now, the statement for square root, SQRT, these are math module itself and are relevant to the programmer. We've been able to see how we went through that, how we're able to call the function, and how we're able to we call the function square root, and then we're able to pass the number inside. So for us to run a function, we do what we call a function call, right? We do a function call. Basically, you call a function. Hope that's clear. You don't. Okay, the process of invoking a function is called a function call. So a function call is the process of invoking function. So the process of invoking a function is called a function call. The item passed. We have an item being passed. Item passed to a function. As we saw, we asked passing the number to our square root. So the item passed to a function is called an argument. I hope that's clear that we have a function, so we do call a function. So a function call is the process of invoking a function. So we call a function. Then we have items being passed to a function called arguments. Some functions have multiple arguments, such as can pass a and b, square root of number 1 and number 2, number 3. Such like is how functions are. Some have multiple arguments being passed. I hope we're clear up to there. So we can do an example too of modules of invoking the math module, calling functions from the math module, then passing through, and then passing arguments. Let's do an example. Do the example 2.py. We can let's go through this then. So as we've been doing, we're going to write here out the problem we're trying to solve. So So we're going to calculate savings. Or just you can just call it as savings. Savings interest program. Now, this is what we're trying to solve here. So let's go through it step by step. So first, we're going to import our module using the math module. So, how is interest? How is our savings calculated? So we'll have the initial savings multiplied by the rate, then you multiply by the years you have, right? So basically you'll have your base basically your initial savings multiplied by multiplied by the 1 plus the rate over 100 times the years. Oh, that's clear. Let me see how you can find an interest savings program. I just want to see how the math calculation looks like. Okay, we can do. Let's go through our program, then we'll come to that. So we'll have our initial savings. So we'll call it this. So we'll say, since we can have it in decimal places. Our user can input in decimal places. So let the user be free to input it in a float data type. So we're going to say enter initial savings amount. Yeah, so basically this user will input their initial savings amount. Then we can do rate. What's the rate? So we're having it in input as well. Input. Enter. Annual interest percentage rate. So the user will be able to input their base, their initial savings, the rate, the annual savings rate, the annual interest rate, sorry. And then we have the number of years which you're going to be having savings in. How many years you have? So we'll we're going to take years in full, so that we don't have 1.5. We want to have years in full, like 1, 2, so that you just take input full years. Basically, we're taking years in full. We won't want to take point years, like half, 1.5. No. Yeah, I guess now with this we've taken input from the user. They have entered their details. They've entered the initial savings, the rate, and the years. Now, how do we know the total? here is where now our math module plays role or plays key role, and we're going to say it's the base amount which we called initially, this one, multiplied by math to the power. Look, we have a function called POW, power. And then we now pass our, so 1 1 plus rate divided by 100, then yes, so our calculation here, our calculation shown in our calculation here is what we're going to use to output the base. Well, sorry, what we're going to output, what we're going to show a savings interest program, whereby we are saying total is equals to, we're going to raise the growth of, we're going to raise the growth to the power of the number of years. This calculates how much the value multiplies over multiple periods. Now that's clear because I'm going to go for more than 1 year. So basically, we've said base is the initial amount we're starting with. This is what we go now. It raises the growth factor to the power of the number of years. 1 plus the rate of 100 multiplied by years, right? So here is the determining factor. So we create total, then let's see what happens. So and the initial amount, let's say 1,000, let's say 5, and we're going to say 3 years. We're going to have 1157.625. So basically we can have we can print it to, now we are from doing the floating point, so we can use the floating point to reduce the number of decimal points we're having. Now let's try and show the user exactly what we are printing out. So we'll say print. We're going to use a savings after. We're going to pass years here. Tell the user we're saving that these years. So basically we pass the years keyword here. So savings after 5 years of whatever years they entered in your terminal when you're being asked this. So whichever depending on the currency you want to use or the currency you're in, so you can use a dollar sign or whichever. So we want to use total here. This total, then savings after these years, total is that. So we can use how to use the floating point notation, full color. right? Use a dot. Then to how many floating points we want. I want 3. Then we say, hope that's clear. Same, how that's clear? Let's see. Sorry. Initial. Okay, let's run our file. So we can say 5,000. 5,000. 1,000. 5 years. So savings after 3 years is 1157.625. Basically, all these are we have our file, our code here. We have executed using this. We have imported the math module, and this is where the math module plays key role. I hope that's clear. Up to that extent, we have been able to cover modules, basically basics of modules, and there's more to modules than that. So we can also have other calculations using the math modules. For now, we can stop it at that. Or we can do one more example using square root of w multiplied by c. Let's do that in our next recording. In case of any questions, let me know. Well, maybe I'll do the import and the likes, and then once we get back, we'll proceed with our programming. Happy coding.